I'll keep this relatively brief. Just thought I'd give an update about something that I think is interesting that we're doing at AboveNet. It might give some people things to think about, and also contact us if you're interested in doing this with us. And so, what we're doing is we're actually, I'll talk about it, but we're doing taking de-aggregated routes from some of our peers, looking to get information about where their customers are located on their network more precisely than are represented by the aggregate routes that we get. So, the routing philosophy that underlies the network at AboveNet is to attract the traffic into our borders by peering widely globally. Unless someone wants, we normally set meds to be basically zero at all our borders, so people hand it to us and then we take charge of the traffic and advertise all the routes at all points globally as 6461 RIS. And cold potato the traffic as much as possible from traffic originating from our colocation customers and ISP customers who are co-located to retain control of the data. And why do we do this? Well, the business case is that the more that we can reduce congestion, the bigger the TCP flows are, which means we get to bill our customers more. Because all the AboveNet customers are paying on a 95th percentile exact sort of non-tiered bandwidth use. So every time we make the network sort of better and bigger, we get money to put back into it. So the network isn't really, the cost of the network isn't really the expense, it's what lets us make the revenue. And also, people time is expensive. The more we have control over the data, closer to the end AS, closer to the end user, the easier it is, the less we have to do coordination with other NOCs, and as people have said, that can be time-consuming and difficult. So, the underlying things, we honor meds. We found that to many networks, honoring meds instead of hot potato does 50% or in some cases much more of traffic increase. I'm not going to pick on any particular networks, but some people are congested. And we get to bill customers for that, but they're happy. Paying more because their customers are happier. So step 2 is take the de-aggregated routes with meds. And the question is, what does a med mean on a /14? I'm sure that you all get all the address space that you want whenever you get it, especially /16 for every pop, so that you can have stuff aggregated geographically, network topologically well, but some providers have problems with that. So taking de-aggregated routes with meds yields about a 25% improvement in traffic flow sizes, the total traffic flow to the ASs that we're honoring meds from anyway. Turning that up to people that we don't honor meds, that aren't giving us meds, now, might be an even bigger improvement. Then on top of that, there's a system that actually monitors congestion, and the basic thing is that when it sees congestion to given IPs, problem spots or flows in the network, it tries to look at the various peering pipes that we have and say, what's the better way to do it? Another thing that we found is that honoring, taking the de-aggregate routes with meds gives this thing less work to do. Because often it's trying to figure out that we have a path to send up in New York, but we're sending it to Chicago and there's some congestion on a given network from Chicago to New York. So why take the aggregated routes? It's hard to get enough address space to do good geographic, or more importantly, network topologic IP allocation. So a /14 or a 16 or a 19 might have customers in multiple cities, but where we might actually have local peering with a given network, whether it's a regional or a large network. So to get an even better idea of the topology, we take de-aggregated routes from many of our peers. Some of the large peers, some of the smaller peers, and we're doing it, I'll talk about that, we're turning people up, trying to, add 3,000 or 4,000 routes a month to sort of, limit the impact on the routers. So we need to have a community on the de-aggregated routes so that we can block sending them to customers, because some customers, there are these nice little 2600 routers which for the access side are much more important news than GSRs were for the backbone side, because it means that a little ISP can multi-home for $3,000 instead of $10,000, which is a huge difference. And they can do full routes today on a couple views, but at 80,000 plus routes, we're not sure. We don't want to blow up any of our customers, so we haven't tried it. But certainly when we get to 100,000, 120,000 routes with this method, we have customers that we know are using, RP SSPs, and we know they won't be able to deal with that many routes. Some customers are multi-homed. So, for example, we take the aggregated routes from another large network. They may get transit also from that other large network. We start sending them these de-aggregated more specifics. They'll send traffic to us that they'd really rather send to the pipe to the other provider. So we need a community so that we can filter on that. The impact has been pretty good. The GSRs just don't care. They're fine. At the level we're at, we've actually tested them via testing up to about 120,000 routes, and they're fine with that even in relatively high churn testing. The 7500s are they're coping with enough memory, 256 meg, and enough CPU snot or whatever. They're capable of doing it okay. Now, that doesn't mean that we're really happy with the code coming out of Cisco and the stability of the 7500s right now, but we're not sure that we can actually point to more routes causing the problem. Causing problems with them rebooting after a few weeks instead of a few months otherwise. Traffic, as I said, goes up with this approach, which is good. It's good for us. It's good for the network that saving bandwidth across their network. It's good for other networks because they can get traffic in then on that free capacity. So, and of course, our customers are happy to pay for the increased traffic flows if we have any. So, ideally, we'd like to take meaningful de-aggregation from all our peers. We, don't know whether we can store 1 million routes in our routers, but we're willing to give it a shot and work with router vendors. We'd like to, even if we're not going to necessarily use them, get something set up so we can take the de-aggregation with communities so that we can turn them on, turn them off if we detect some sort of congestion problem in a given peer's network. So we're going to continue the process heading towards about a goal of 100,000 routes, or basically, as a total, we don't know what the internet routing table growth will be, but most of that growth would be from taking additional routes by the end of the year, and hopefully somewhere in the 200,000 range next year. So when we have switch vendors come to us and say, well, we have these wonderfully fast switches, and they can do 65,536, prefixes on an ASIC, and we go, well, we already have, 80, 100,000 routes on some of the routers, and they say, well, that's not the internet. And we say, well, that's not your internet, but our internet is a little bit more diverse. And so ask them a question and say, well, I remember this beautiful little router called the AGS and the 7000. And so what you're saying is that each of the line cards in your switch can do 64,000 routes. So what happens if I hook a box up to it and send packets to 65,537 destinations? Is it going to make incorrect forwarding decisions, or is it just going to thrash its brains out? And I still haven't had an answer on that from the two vendors that are trying to sell us switches, but it'll be interesting to see. And I'm almost done. So, any questions? If people are interested in participating in this, if you already peer with us, and we probably peer with we have very open peering policy. So if you don't, you certainly should. You can just send us mail. We'll turn that up. ENG is the internal engineering mailing list. Peering also goes there. Or myself, Avi at AboveNet, or Dave Rand, who really, this all was his idea. So DLR at AboveNet. And I guess we can all get food. Is there free food, or are we all off on our own? Oh, well, okay.
Can I make one comment?
Oh, please, sorry.
My name is Vince Fuller. I have a nodding familiarity with CIDR, as some of you may know. I would actually appreciate some comments from some router vendors on whether this is a really valuable thing to do, because what you're doing here is inherently non-scalable and is inherently reversing any progress that has been made by CIDR in making internet routing grow in a somewhat less than exponential rate. The problem with routing in the internet has never been fundamentally constrained by memory size. It's been constrained by thrashing and CPU speeds and the growth of those factors. What you're doing here is you're basically putting the internet back onto an exponential growth curve.
Inside our network, yes.
Inside your network. But if you're advocating that this be tried elsewhere than on your network, you're advocating creating an exponential growth problem again.
That's true. I mean, and again, that would be for router vendors to comment. We're optimistic that they'll be able to support, once the FastEs work, we hope to toss all the 7500s off the 22nd floor of 50 West San Fernando in San Jose.
The problem is not the 7500s. The problem is a fundamental property of growth. CIDR has caused routing to start growing linearly instead of exponentially. You are not going to beat an exponential growth curve by depending on router speed to increase or memory size to increase at a similar rate. This was hashed out years ago in CIDR-D. And I'm just telling you that this is not going to work on a global scale.
There are other factors in terms of, okay. Well, we're happy to send more traffic this way. I mean, we see that at the current, okay. And those are?
They do not involve routing.
Okay. I guess if everyone went on a completely decongested network, then we wouldn't be looking at doing some of these things. But yes.
The mic's on.
Oh, sorry. Yes.
Thanks. Fab from Torrent, Ericsson. I think the issues with CIDR were certainly, or the purpose of CIDR was obviously to control routing table size. I think we've kind of jumped to the next phase as far as handling routing issues like this. Obviously, IP switching was pretty big a couple of years ago because folks were concerned that CIDR, or that the problem of aggregation was going to be so severe that we'd have to move to things like IP switching, et cetera, keep our routing table sizes small, and then move over to IP switching to solve it. But I think now with our gig routers, terabit routers, we're starting to address the route lookup issue. In our current implementation, we're scaling up to about 500,000 routes at full wire speed with quality of service, diff-serve, and also implementing things like MPLS. So we're certainly moving towards getting away from some of the basic issues in route lookup. I'm not saying that CIDR has to go away or anything like that, but the way the issues were, the issues 3 years ago are different from the issues today, I think. And then, of course, IPv6 comes into the scenario, and we have to figure out how that's going to affect things. But we think we can address some of the things that Avi's trying to do on a larger basis. Not to say that CIDR is something that needs to go away.
And my two comments would be, we've heard that from other router vendors. We believe it about as much as we believe, well, I won't go there, but we're optimistic, that's right, and this works for us. We like this approach, and I'm sorry if it offends anyone to suggest that other people do the same.
Sure. Just one comment of my own, that there's other properties than just the router, memory, and CPU, but there's inherent properties of BGP, little things like convergence, which are highly dependent on the number of paths available.
That's true.
So.
And I was going to say, actually, another approach is to be constantly seeking to get additional paths, which actually does help with some of this stuff as it scales. But yes, I mean, we're not unaware of some of the people at AboveNet are very, very aware of all the architectural issues. Some of the people used to work at Cisco, and of how you build a router that does these sorts of things. But,
right, but it's not just per router. You have an entire, from a whole network point of view, as well, things like converging.
And there are things that you can do to reduce some of that. There's BGP scaling methods that you can do for that.
Well, thank you.